I have a quantum field theory permitted solution. I've got a 100-page study on the covariant action, the renormalizable scalar field. I meet all of the standards of quantum field theory and effective field theory. I've also got a 100-page study of every other scalar field in the world, and I can see where my theory fits in to that peer group. And I can see that I am distinct and unique in having continuous density-dependent modulation. No other theory has that for an all-pervading singlet scalar field. That's unique. But I also pick up a lot of the factors and characteristics that are part of the other scalar fields. So, expanse tension.
Ladies and gentlemen, brothers and sisters, boys and girls, I am so happy to have you joining us again today. Today I've got a fantastically fascinating guest. His name is John Holland, and he has been working on what could be one of the most universal theories. What we've done so far is we've been able to talk just a little bit beforehand, and he started going into some of his fantastic discoveries and some of the accolades that have come along with it. But I'm going to just let him explain what GETT is in his own words. John, why don't you go ahead and introduce what you've been doing and how it fits into this giant scope of...
Well, Adam, look, thank you so much. This is a great opportunity. So I got to start at the beginning. 1986. I'm 10 years old. I'm at primary school. My headmaster, he delivers to the class a lesson on what Newton and Einstein had achieved, but he was very clear on what they had not achieved. So Newton has proposed calculus to describe what gravity does. Einstein has proposed geometry, curvature of space-time geometry of what gravity does. But 40 years ago, I was told very clearly, under no uncertain terms, there is not a matter-energy physical real causal mechanism of gravity. And he had us jumping up and down to experience gravity and think about what we were experiencing. And the question was, why? Because neither Newton nor Einstein had established why to physical matter-energy cause. So I've been obsessed with that. He set me a challenge. I'm frustrating and stubborn, and 40 years, I have read science relentlessly in the pursuit of the causal mechanism of gravity. So that's my background. I'm a chartered engineer. I'm a Six Sigma Master Black Belt. I've specialized. If I'm anything, I'm a professional problem solver. My career is a professional statistical problem solver as a Six Sigma Master Black Belt. Last summer, it was August 4th. I was on an aeroplane from the UK to Morocco at 29,000 feet. And for the few weeks before that, bizarrely, just for fun, I was researching both the Hubble tension and scalar fields. Okay, so this is just kind of what I do for fun. So I'd established that the Hubble tension is a tension of the expansion rate of the universe, somewhere between 67 and 74 kilometers per second per megaparsec above us. So up here, somewhere, a long way away, the universe is expanding between 67 and 74 kilometers per second per megaparsec. Now, I sat on that aeroplane at 29,000 feet and looked up and thought, that's what's happening above me. But below me, they're not experiencing that. And I'm not experiencing that here. So I have what I think and what has actually become quite a profound thought. What if mass resists expansion, and if you adopt a quantum scalar field as a real all-pervading medium, which are fully permitted in quantum field theory, a gauge-invariant singlet scalar field, well, then that acts as an elastic medium. And if it's expanding up there and not here, then we experience a net flow imbalance in that expansion and the expanding scalar field. And as an engineer, I know if you have a net flow imbalance, it introduces tension gradients. And wherever you have a tension gradient, you have a restorative force. Okay, so try pinning an elastic band to the tabletop and pulling it, dragging it up. If you want to know which direction the restoring force is in, let go of the top. Okay.
Yeah, there you go.
There you go. So 4th of August last year, I have an idea that gravity is the restoring force of a singlet scalar field being resisted in its expansion by mass. Now, within a week, I've been using some online quantum field theory calculators to put those numbers into some quantum field theory construct. And I was as careful as possible to avoid any Newtonian maths or construct of inverse square law, and to avoid all Einstein field equations completely. And to see, can I use quantum field theory to calculate gravity? Okay. Now, I put some numbers in, 70 kilometers per second against nothing, against the mass density of the Earth. The first number that came out of that calculator was minus 9.81 meters per second downwards. Okay. I fell off my chair. Okay.
It's a good number to land on. Why don't you tell people why that's significant?
It's gravity. It's gravity, the acceleration due to gravity as calculated by quantum field theory. It is a step towards the unification of classical gravity of Einstein and Newton with quantum field theory. So then I proceeded to repeat that experiment with the Moon, Saturn, Mars, and the Sun, and the numbers all came out flawlessly according to their known gravitational attractions. So this is a real pervading physical scalar field, a restoring force that gives us what we know as gravity. And that's quite a big deal. If
That is a big deal.
that's that's the first ever construction of a physical explanation of gravity. But that was 8 months ago. And I will say, Adam, that was my only goal. My life goal objective was to find the causal mechanism of gravity. That's it. That's all I set out to do. Nothing else. Nothing else. So at that point, I set about trying to communicate and share with scientists, and people say, I think I found something. There is a hard, closed, locked door of the science community. So whilst they ignored me and gave me the cold shoulder silent treatment as a potential deluded narcissistic armchair physicist sitting at home, okay, so I proceeded to apply those ideas to other things. And 8 months later, I have a theory. I don't like the term theory of everything for this. So Stephen Hawking used it, theory of everything, and he said, well, actually, it can't explain love and emotion. So he said, don't use those terms. But a unified single field theory of foundational physics will about cut it.
I think that's a very appropriate adjustment.
Yeah,
for sure.
To everyone else, it's a theory of everything. But
there you go. When we're talking in physics, theory of everything is pretty much used as a blanket over physics, not over love, not over, some of these aspects that obviously land outside of physics. But go ahead, carry on.
So what did I start? So the theory then started to develop and evolve. So expanse tension theory, ETT, is about gravity, cosmology, inertia. At that point, I believe I'm the first person not only to describe gravity, but the causal underpinnings of inertia. We do not know why inertial energy is half mv squared. Why? We don't know what causes inertia. We don't know. Oh, by the way, we don't really know the causal reason of weight. Weight, defined in expanse tension theory. So I then start reproducing gravity, planetary orbits, and I take quite a deep look at a dark matter problem, flat rotation curves of the density of outer regions of galaxies, and very quickly established that this all-pervading scalar field that I'm using, if it couples with mass in the low density regions, it can provide inner strain on those outer regions of galaxies. So let's just explain what this is. So where we live in the mid density, the scalar field is uncoupled from mass. They are uncoupled. There's an expanding scalar field resisted by mass, and mass is uncoupled from it. You go all the way through the solar system into then galaxy. And if you get to the extreme low density of the outer halos of galaxies, there's a transition, a threshold boundary, which I've calculated. And it's quite a big leap. It says at that point, the expanding scalar field becomes coupled with the Higgs sector mass. They can couple. And effectively, it creates an inner strain on that matter. Now, matter forces hold together, okay, but they're put under the strain of being pulled by this expanding scalar. That gives us this hidden pull of dark matter. So dark matter does not exist. Right? There is no dark matter. Now, if you look at every single instance of inferred dark matter, it's in the extreme low density space. Okay, the outer halo regions of galaxies, low density, void lensing, the clues in the title, void lensing, the bending of light through apparently nothing. And then things like these super giant supercluster galaxy flows that we'll be looking at, where we look at this sink basin that we're all flowing into as giant galaxy clusters. Again, all of it exists where you've got a very extreme low density transition. So the theory developed into a theory where mass resists expansion. There's a scalar field. The scalar field can couple to mass beyond a low density boundary. Okay, that's expanse tension theory. I then started researching late time acceleration, dark matter, and used the opposite, used from the Big Bang. What if mass and the scalar field uncouple to release late time acceleration? So if it was previously mass coupled to expansion, well, if mass could uncouple, it would release the void to expand faster. So again, I then developed a theory that explained dark energy through void dynamics, through uncoupling, and that worked. I think I got a statistical chi-squared test of 0.985, a statistical proof of dark energy. Dark energy doesn't exist. It's an uncoupling of the scalar coupling. So that's exciting. Then I could keep going. In fact, wow. So then I started looking at glitchy neutron stars, compact objects, pulsars. Fascinating. An entire class of compact objects display various ranges of erratic, energetic, unexplained, anomalous behavior. Glitchy neutron stars. So we started to look, well, actually, what if in the extreme high density space, coupling is triggered again? You know, what if coupling triggers in the core of a neutron star or pulsar? Now, the outer crusts of neutron stars are within a density where this scalar field is uncoupled, but the object core can couple, triggering what is known to be an inner core driven anomaly of erratic, glitchy behavior of neutron stars, the whole class of neutron stars. Okay. And you start to see signatures like the smoking gun. What are zombie stars? So there are stars called zombie stars. They appear to be huge compact objects or dense compact objects, but they're not glitchy because they haven't passed a threshold that would trigger the inner core glitchiness. Okay, so inner dynamics are basically tearing the inners of these compact objects apart, which is then visible as pulsar, radio transit pulsars, for example. Okay, so then I've got a threshold for coupling in the low extreme and the high extreme and the extreme late time acceleration. So I'm building up a map of how scalar field coupling can describe cosmology. Then something really cool. So then there's a series of further leaps. This is true. So in 2012, CERN, Geneva, proved that a quantum field theory process, electroweak symmetry breaking of the Higgs field, assigns matter with the property mass. So, by deduction, mass is emergent of a quantum field theory process. So we use mass for everything, but I'm now saying mass is emergent because it is a signed property. Well, what about everything that's proportional to mass? So gravity, inertia, and time must also be emergent phenomena, since they're proportional to something that's emergent. Yeah.
Say that one more time. I want to make sure that I fully comprehend what that is, because that chain of thought right there is fundamental to, I think, where you're going.
Yeah. So electroweak symmetry breaking of the Higgs VeV assigns matter with a property characteristic mass. What is mass? Mass is matter which experiences gravity, inertia, and time dilation. Okay, we have an incomplete definition of mass beyond inertial mass. So it's almost cyclical. Well, what's mass? Well, it has inertia, gravity, and high mass can cause time dilation. So if electroweak symmetry breaking causes matter to possess this property mass, then it must be emergent. It's assigned through a quantum field theory process. Now, that's quite a big deal. So if you look up Freeman's law, if you remember your electromagnetism, you end up doing this in your hand in an exam and you go, well, hang on, it's current and voltage resistance, Freeman's law. Well, what I say is electroweak symmetry breaking triggers the orthogonal emergence of gravity, inertia, and time. Okay. Now, then it gets interesting, because if you then go to the early universe, so electroweak symmetry breaking in the description of the early universe is something like step 5. So Big Bang, step 5, electroweak symmetry breaking. Now remember, in the Big Bang, you supposedly have a mathematical singularity, a point of infinite mass that kills physics. Now, if step 5 after the Big Bang is electroweak symmetry breaking, my deduction says, well, before electroweak symmetry breaking, you have not had the emergence of gravity, inertia, and time. And therefore, you can avoid the singularity at the Big Bang because there is no gravity. That's in
Because
the...
until those become isolated properties, you don't have mass.
Yeah, exactly. Now, I then took another leap and said, well, hang on. In the collapse of a black hole, you're heading to the same ultra high dense mass at the core of a black hole. We've got to avoid the singularity, which kills physics. Well, what if symmetry restoration in that ultra dense region of a black hole de-emerges mass, as in de-emerges gravity, inertia, and time? So at that point, just before you head into this infinite singularity of a black hole, gravity, inertia, and time they don't freeze. They cease to exist. They de-emerge. Now, I think this all is a deduction from the 2012 CERN result. I think this is all a straight deduction from what CERN have told us. And I can't imagine how, this for me comes out of the CERN result. So that's what list have we got so far? So we've now said we solved gravity, inertia, and time to causal mechanism. We've eliminated dark matter and dark energy, and we've eliminated the singularity at Big Bang and black hole, all with a real, all-pervading quantum field theory permitted gauge invariant singlet scalar field that couples to the Higgs sector via continuous density-dependent modulation. It's pretty cool.
It is very cool. I love its self-consistency, and I think so. I've watched your work for a while, and one of the things that stands out is not only, your background, but when I read and look at your work, the discipline that's gone into it is obviously evident. And one of the things that I have recently kind of has surfaced for me that maybe didn't when I first started watching and reading some of the publications that you'd put out was the emphasis on how scaling has become more and more significant, it feels like, throughout your continued work. Why do you feel like that has sort of taken a more increased role in some of the recent work?
Scaling. So,
Your scaling coupling.
oh, the scaling. So it's probably worth talking about getting into the correspondence series, and we'll talk about that. So this the reason why I think this is valid is I've always believed there is a medium to the universe. Okay. I want to move beyond geometry. I think we need a scalar field. I think we need a medium to the universe. And I think the whole portfolio lends itself to say this is now looking like there is some form of all-pervading quantum field scalar to the universe. It probably brings us to one of the most famous experiments ever in science, in history, the 224-year-old Thomas Young double slit experiment paradox. Okay.
One of my favorites.
Now, this is brilliant. So, for 224 years, we've seen the interference pattern of light being shone through a double slit, implying wave-particle duality, particle superposition, the Copenhagen interpretation of an unknowable probabilistic universe. I don't buy that at all.
Okay.
So about 100 years after Thomas Young, a guy called Taylor was firing individual particles one at a time. That was the real test that said something was going on. He could fire a single neutron or a single electron, single particle firing, one at a time. Can he still experience over time, by replicates of that, he's still got the statistical interference pattern. Now, it was Taylor's work that led to the full wave-particle duality of quantum mechanics through the 1920s. Now, if you drop in a density-dependent singlet scalar field that's all-pervading, the field propagates the wave. Particle remains a particle. It's guided within the low-density regions of the wave, which is the wave passes through both slits. The wave interferes, the scalar field wave propagates with itself on the other side. It's there all of the time. The particle just rides the wave at its lowest density interaction. So in my Solving Science video 14b, there's an animation that if you insert an all-pervading field, your field propagates the wave. And the wave is the interference. Particle remains a particle. Now, that's amazing because it gets rid of all quantum mechanics weirdness. You know, all of this wave-particle duality, probabilistic, an indeterminate universe, the thing that Einstein hated, the famous quote from Einstein, God doesn't play dice with the universe. It's not probabilistic. So again, Einstein would be happy. He'd like my work because it says we're not living in an indeterminate probabilistic universe.
Awesome. That is a really, really well put. And one of the things that I guess we have also looked at previously in science is a pilot wave theory. In some ways, what you're talking about here echoes with the pilot wave theory.
Yeah, I think, was it de Broglie's pilot wave theory? He does, because with his pilot wave theory, again, throughout history, people have made attempts to bring in a medium. Again and again and again, they're making attempts. It's probably an issue in physics. I'm not a PhD, which means I haven't studied my subject to an infinite depth in a narrow band. I'm a generalist. I'm studying all types of physics. And what I see is people trying to solve problems in a very narrow, limited band way. And pilot wave theory is it lacked, it reached the idea that there was a medium, but it didn't take the step of saying, well, that medium, it must be all pervading across the entire known universe. So most of these theories get partial. And the paper on scalar field comparisons shows that hundreds of people are studying scalar fields within a limit of their PhD research. So there's a scalar field designed for galaxy dynamics. There's a scalar field designed to solve late time acceleration, dark energy. There's scalar fields concocted to solve the early universe within a limited domain of someone's PhD research.
So you're saying, why are they all independent?
Yeah, maybe the advantage I've had is I'm not focused on a particular area. I've been able to sit back and look at things more holistically. Maybe.
Absolutely, absolutely. And every one of us has got a unique history, and your unique history is going to allow you to filter things through all the journals that you've read, through your engineering experience, through life lessons. Many scientists throughout time have come from disparate fields, and they've broken in through basically sheer discovery. Einstein is science's, poster boy for the fact that we go from a man who's working in a male house to a guy who's writing patents and then who ends up finding fundamental physics.
Yeah. That's a good point, actually. So when I first started, all the AIs were falsifying my original thoughts and ideas because the AIs would throw at me and say, well, John, this doesn't work because the answer is dark matter. And I said, well, no, dark matter is a theory. So no, all the AIs were saying, no, John, what you're proposing is wrong. The answer is dark matter. And I would have to end up saying, no, 92 years, we haven't found any dark matter. I don't think it's there. Yeah. And then it would say, well, no, the answer to that's dark energy. Again, you'd have the same argument. One of the biggest arguments was General Expanse Tension Theory universally breaks the equivalence principle. That's a pretty big deal.
Explain why that's a big deal really quick.
Well, it's a big deal because in every single human test of the equivalence principle that we've ever made, it stands absolutely 100% rock solid. So the equivalence principle is taken for rock solid, unbreakable science. Until I came along and said, yeah, but humans have a limited scope on the cosmos. We exist within a tiny fraction of the density orders of magnitude. Yeah, our experience does not span the order of magnitude of the extreme density of the Big Bang or of a black hole, or we've never been to the outer regions of a galaxy. We've never been to the cosmic void. So I took a leap and I was happy to say I'll break the equivalence principle because inertial mass will change based on the coupling of the expansion field to matter. There will be a shift in the equivalence principle. Okay, our limited human knowledge doesn't apply in these domains. Now, that then leads to something else really exciting. There are currently 5 deep space probes, 5 human deep space probes. Now, go and look up the Pioneer anomaly. Okay, go and look at everything that Voyager 1 and Voyager 2 are experiencing now. Go and look at what New Horizons is experiencing. We've got 5 deep space probes that are all near to, at, or beyond my density threshold, and they are almost all displaying anomalous behavior. Okay, so there's all sorts of things happening with our deep space probes, and I believe they have passed beyond a density threshold as predicted by General Expanse Tension Theory. So,
Interesting. What do you think that's going to lead to?
well, to be honest, I think someone needs to look at my theory pretty quickly, because if we're going to send up more and more deep space probes, we need to know and predict how additional coupling between the mass of these probes and the very deep void of space will cause problems for our probes. So that gets me actually from the upgrade from expanse tension theory to general expanse tension theory was a big step. So prepare yourself for this. Expanse tension theory was simply the coupling of mass to the scalar field. The general expanse tension theory says, well, why can't we couple all particles, all entities in the standard model of physics to the scalar field with the same density dependent modulation? Okay. Now, so in the standard model of physics, there are 19 entities measured in about 27 ways of parameters. They are all considered fixed value constant parameters, universally fixed values.
And so your argument is that they're fixed, and when we end up in the outer regions of space, that scaling coupler is not fixed, and we're going to have some sort of something. I don't even want to try to guess.
Yeah, So the argument is the 19 entities in the standard model of physics in general expanse tension theory become environment-dependent variables. So when we say the mass of an electron is x, beyond a density threshold, the mass of an electron could change. Okay, because it becomes coupled to the scalar field. Now, the extreme end of GETT with what's called the universal coupling modulation equation is that you can actually then construct a single unified field.
Yeah.
As in, you get to the point where you're saying, well, there's an electromagnetic field, there's the electron field, there's the Higgs field, there's the Holland field of expanse tension theory. You can get to the point where you say, well, we can then have a single unified field equation. And that's what is in what's called expanse tension theory, general expanse tension theory upgrade.
That's crazy. It's really fascinating. All right. Well, John, as we wrap up, do you have anything that you feel like maybe we haven't really talked about, or something that you feel like? I think I have one or two more follow-up questions, but do you feel like there's something that you feel we should really start to, before we leave, what should we make sure we don't miss?
So, yes, it's called the GETT Correspondence Series. Now, this is mind-blowing. So the term correspondence is in science is where new science must encompass, encapsulate, and explain old existing trusted science. So, for example, Newton's work ran a correspondence of Galileo and Kepler. Einstein came along, ran a correspondence of Newton, and put Newton in a domain limit of where Newtonian gravity works. And then there's a new Einstein. So the correspondence, never in history has anybody ran a correspondence series of special relativity and general relativity. Now,
Okay.
never in history. So if you go to my website, so at www.expansetensiontheory.org, under correspondence, you see the correspondence series. Paper 3 is a full signed off 100% proof of correspondence to special relativity, Lorentz invariance. Paper 4.1 is a complete correspondence of the metric structure of space-time, a world first with a scalar field. Paper 4.2 is probably the biggest thing I've ever worked on in life. It completely reconstructs the dynamics of gravitational attraction under Einstein and reproduces all of the Einstein equations within their limited domain. The paper I've just published, 4.3, takes the 9 predictions of general relativity, the ultimate 9. Again, quick list: the perihelion precession, like of Mercury, gravitational redshift, gravitational lensing, the Shapiro time delay, time dilation, gravitational wave propagation speed, geodetic precession, university of free fall, frame dragging. The 9 things that general relativity predicted have all been reproduced within a domain limit of general expanse tension theory. Now, what have I done? What's my claim? I think I've put Einstein in a box, just like he put Newton in a box. I think I put Einstein in a box labeled general relativity domain limit. Okay. Now, it's very clear to me that there is a domain limit based on density. And what we see is the weak field where we have adiabatic processes, slow transition of time and dynamics. We don't have any really sharp gradients. We don't have these massive disruptive pulsars and neutron stars. We don't have the deep void. So what that paper shows is general relativity fits within a domain limit. Now, the paper I'm working on today, paper 4.4, it's going to be published in the next few days, is beyond general relativity, and it proposes why general relativity works where it works and where it fails, and then goes beyond Einstein. And that paper then proposes resolution to everything that Einstein general relativity can't predict. So dark matter, dark energy, the Hubble tension, singularities, void lensing, all resolved in paper 4.4. So they're all there. That's pretty cool.
That is very cool. And I want to follow up that. One of the things that we had discussed before and we had talked about is sometimes what is your predictions, right? Physics gets very particular. If you can't make a prediction, is it really new science? And you've probably heard that kind of argument before. It's one of the dances that you've had to put on for many years, I'm sure, for at least for many papers. How do you combat that now? What is your current frame for that?
So every single paper published, and there are now 40 papers published in the Zenodo archive. Every single paper published has a falsifiability section, and it lists the tests that could falsify the claims. So I've been really strict in doing that. So for every single subject, there's a falsification section. But I'll raise one that would be really easy, that we could do really easy. If we had friends with a laboratory, a physics lab, we could do it really easily. So there's a paper called the Richard Feynman glass reflection paradox. Amazing. What an amazing. Go and read about the 1986 Richard Feynman glass reflection paradox. What a stunning paradox Richard Feynman left us with. To summarize, if you shine light at a glass screen, an amount of light will reflect off that screen. If you change the amount of bulk material in the background, the amount of light reflected off the front surface changes. And the paradox is, it implies that the photon of light at the front surface has some innate knowledge of the bulk material behind it. Now, summarizing a 120-page proof, it's because of a density-dependent scalar field where there's a tension gradient around the entire bulk material, changing the interface of the wavelength of light as it hits the front screen. So the inherent scalar field changes the reflection of the photon hitting the front screen. Anyway, that's a detail. Now,
Fascinating.
that
I was not familiar with that paradox, though, so thank you.
It's really cool. Now, here's the thing. That paper lists about 10 ways to set up glass reflection experiments to prove it's a density-dependent scalar that's triggering the reaction. Because the rare bulk material doesn't have to be glass. You can actually show differences in bulk material with different densities and actually show you can affect the amount of reflected light. So there's a whole series of experiments that we can show and falsify whether there is a density-dependent scalar field. And again, very low cost. Although the real test I want, there's 15 kilograms of hydrazine fuel on the New Horizons probe. I would love to burn some of that fuel in a sideways trajectory burn, because I believe New Horizons has crossed into the coupling zone of the low density regime. And if I could burn a little bit of that fuel on New Horizons, within 5 years, I think that probe would be 70,000 kilometers off course, because there'll be a change in the equivalence principle. So at some point, I think it's JPL who own that, but at some point I'm going to go to NASA and JPL and say, would you allow me to burn some of that hydrazine fuel in a burn to see, can we put New Horizons probe somewhere else where it's not expected to be?
Wow. Yeah. Now all we need is NASA to sign off on that, John, and we'll be set.
Yeah. So
5 years later.
yeah. So that's pretty much where I am. So the website now has been launched as a collection of the whole portfolio. There's a YouTube channel that's grown to about 24,000 subscribers now. So all my videos on the YouTube channel. I'm trying to be as transparent and open as possible, invite scrutiny, and everything's been published for people to look at. The physics community is a locked, closed door community. I cannot break through. So in the meantime, I'm just going to keep. So with the peer review saying the mechanism is consistent with quantum field theory, I'm now emboldened to say, well, then my work is plausible, credible, feasible, I'm going to keep going. So just behind me, I've got a list of the next solving science things I'm going to solve. I've got a list of 15 or 20 things that, and I can see already I can solve. I can already
Sure.
see. So I've got a long list of solving science things I'm going to solve. My correspondence series, I'm going to look at thermodynamics next. I'm going to show thermodynamics. I've got to get into void lensing. So I've got all sorts of, things that come next. Then I want to really dig into quantum mechanics to really prove we can get rid of this Copenhagen interpretation that Einstein hated.
Beautiful. I love it. And I just feel like I have been treated to all sorts of special thoughts from you, John, today. Uh, I can't even say all the words that I feel like, and I don't want to detract from any of your words. So I'm going to just say thank you for joining. And I hope that we continue to stay in touch. I'm looking forward to watching and reading all of your future papers. I've visited your website. I've watched not all of your videos, but I've watched a spattering of your videos, and I continue to be impressed by your clarity of thought and your discipline in your craft.
Oh,
And I've been really impressed by it, and I'm happy to let everybody know. Go ahead and let people know where they can learn more about this, how they can contact you, and we'll be able to wrap up right there.
well, Adam, thank you so much for your support, your interest. Honestly, that means the world to me. This is a lonely game, sitting in an office without academic professors or institutions to talk to. So this is quite a lonely space. And that's now what I desperately seek, is to have conversations with physicists who are just interested to explore. And I hope there are people out there who are simply bored and frustrated at being told about dark matter, dark energy, the Hubble tension, singularities, which we can't explain, and actually want to move forward. There seems to be too many people being paid to just talk about these 92-year-old problems that we haven't solved. Well, they're all saying, hey, we're really open-minded to new ideas. My experience is no, they're not. So open-minded physicists to come and just have a chat and explore. That's what we need.
I agree. Put it to work. John's
Right.
data's out there. The numbers are out there. The math is out there. If you're working in the field, see if you can't take advantage of some of those things. Prove it yourself.
So, Adam,
And
I'm going to say, sorry, excitable. So I'm excitable. There's always one more thing with me. There's one thing.
always.
Always one more thing. Okay. I went to the European Space Agency, the Gaia DR3 mission, downloaded a random 6 million star sample and studied vertical velocity. So about the midplane of the galaxy, vertical velocity rather than rotational velocity.
Okay.
That paper, Milky Way, vertical velocity, proved to 99.998% statistical confidence that the onset of anomalous dark matter vertical velocity is exactly at a baryonic mass density of 10 to the minus 21.6 kilograms per meter cubed. Okay, so the onset of anomalous dark matter in our galaxy is at a density point, and the paper proves its density is the factor that triggers the change. Now, that's a sample of one galaxy, despite it's a 6 million star sample. I replicated that on rotational velocity in 175 spark galaxies and proved to a 0.983 chi-squared test. The same density holds in 175 other galaxies. So, purely empirical data from peer-reviewed, publicly available information. Anybody can go and download that data and say, what's the onset coarse-grained baryonic mass density of dark matter from either Milky Way or from the Spark Galaxy databases? Other databases are available.
Sure. And they're going to see those numbers line up.
Well,
That's amazing.
or I've got it wrong. I mean, I have spent 30 years as a Six Sigma Master Black Belt using data to study and prove things. So that has been my career is, testing hypotheses. So anyway, I had to mention that because that takes away from theory. That is pure empirical proof. Anyone can go and do that and replicate that. Tell me, do their numbers come out the same as mine?
It's great. And I think what's fascinating is we continue to find different measurements throughout the universe coming from different fields, coming from different areas, and we're able to slice through that data and put GETT to work and see that, hey, look, these things still align in different fields or from different measurements or from different tool sets.
Yeah, agreed. Well,
It's
Adam,
amazing.
it's an absolute pleasure, real pleasure to speak with you. Thank you so much for your interest.
Absolutely. Thank you for joining today, John. And it is a pleasure for me to have you and to be able to hear your thoughts. So we'll look forward to speaking again real soon.
Oh, bless you.